Hello, I'm Greg McMaster, your instructor. We're going to be adding aeronautical charts to this segment here. There's going to be some questions on the test, on the FAA Aeronautical Knowledge Test, and although in our previous 5 courses there was a basic understanding of charts, now we're going to dig a bit deeper and show you what these charts do, how they work for you, and how you can read them and interpolate them and use them to your benefit. So what is a chart? Well, it's a map that's provided by the FAA or JEPSON to provide the pilot with a detailed portrayal of information concerning the flight. So you've got 2 different types of charts that are coming up here on the screen. We're going to go through the one on the right more than the one on the left, but the one on the left just gives you a basic idea of what the chart on the right means. See those little boxes on the left-hand side of that screen with all those little boxes in that national map? Well, that map to the right is just one of those boxes. So to start, before we talk about anything else about the charts, there's going to be black lines that go up and down, north to south, and they go left to right or east to west. Now, those lines are latitude and longitude. The latitude lines, the line that parallels the equator, those are east to west, and they lie flat. So F flat, so latitude. And north designation for us, well, we are north of the equator, right around 35 to 43 degrees, where we do most of our work and our flying, at least here with CTI. Now for the longitude, the lines that parallel the prime meridian, that is north to south. Now they're longer because the Earth is basically not a ball on the map, it's just showing it as flat, so it's going to be a bit skewed. And west designation for us, well, we are west of the prime meridian, so it's going to be showing anywhere between 108 to about 135 degrees, depending on where you are in the United States. Now, the latitude and longitude degrees come down to degrees, minutes, and seconds. Now, while the seconds are displayed on a chart, pilots aren't usually using seconds. We just estimate to the nearest minute. And for the purpose of what you're going to be doing with NOTAMS, getting down to the nearest minute is certainly going to be very close enough. And we'll tell you and show you how to do that coming up in a couple of minutes. Now, on this chart that you see popping up on the screen in front of you is basically 1 degree. You've got 1 degree, 121 degrees on the right side of the screen. On the left side of that box, you've got 122 degrees. When you look down to the bottom, you're going to see a dot. That's an airport. And it's located at 36 degrees, 47.5 degrees north, and 121 degrees, 38.0 degrees west. Now, determining latitude and longitude, you're going to want to notice the tick lines that separate those degrees. From 121 to 122, you're going to see a lot of tick marks in there. What are those tick marks? Well, those are the minutes, and you can break them down even more into seconds. So here's an example. What does the line of latitude at area for measure on this sectional chart right here? You've got an airport just to the south. You've got that line that goes from the left side of the screen to the right side of the screen. So think about it for a second here. What does that line of latitude at area for measure? Is it the degrees of latitude east to west of the prime meridian? Or is it the degrees of latitude north and south from the equator? Or the degrees of latitude east and west of the line that passes through Greenwich, England? For the case in this one here, you can rule out C and you can rule out A. The answer is degrees of latitude north and south from the equator. Now the latitude and longitude, I want you to find this place on your own. On the next chart that pops up on the screen, what is the longitude and latitude of Cherry Capital Airport, otherwise known as Traverse City Airport? So as the screen pops up in front of you, you're going to find Cherry Capital Airport pretty easily because it's one of the larger circles that are there with the airport. So while we put this on pause real quick, I want you to try to figure out what the latitude and longitude is. Do you think you found it? Well, here's a hint. If you came up with something relatively close to 44 degrees, 44 minutes, and if you wanted to break it down even farther into seconds, you could go 495 to the north. And 085 for 85 degrees, 34 minutes, or if you did 35 minutes, you were definitely close enough. So when you go back and look at the chart, if you're still trying to figure out how those tick marks work, you had 121 degrees and 122 degrees. Those tick marks in between are minutes, and there's going to be 60 minutes in between those degrees. You don't have to worry about the seconds. Only computers aiding are able to get it down to seconds. If you want to try it, go ahead, but for our purposes in this course here, getting it down to the closest minute certainly is going to be close enough. Now let's talk about the projections. You've got a globe chart, which is a Mercator projection, which is like a wall chart. You walk into an office building and you see this huge wall chart. That is a Mercator projection. There's a flat chart as well, Lambert conformal conic projection, which is what we use for aviation. Now, do you need to know that when you come into the FAA test? Not necessarily, but it is good to understand the concept of what chart and what it means and how it's used. So the chart that's going to be popping up next on the screen, we're going to be talking about an airport that is located approximately 47 degrees and 40 minutes north latitude and 101 degrees, 26 minutes west longitude. So get the paper and pencil out. Here are the numbers again. You want to locate 47 degrees, 40 minutes north, and 101 degrees and 26 minutes west. Try to find the closest airport. Did you find it yet? When you're given degrees and minutes first, you just work with the latitude and longitude lines. And you'll be able to zero in the bottom left-hand corner of the screen. And the answer, if you came up with Garrison Airport, you were correct. So for the terminal area chart, it's a lot of boxes, a lot of purple boxes that you see right there. And that is if you're going to be flying in a very condensed area. Think of Southwest Michigan. If you look at the sectional chart that you have here, then the terminal chart is that little purple box because of the amount of activity. We talk about towers, cell towers, anything that is going to be an obstruction to flight is going to be condensed in that area. Now, every chart has airport symbols, and the legend is usually in the bottom left or bottom right. So as we pull the airport symbols up full screen, you're going to be able to take a look and see the detail of what this legend means. So let's go through that for a moment here. You've got airports, and there's different circles. Some of them aren't even a circle. You've got hard surface runways, seaplane bases. You've got hard surface runways between 1,500 feet to over 8,000 feet in length. Down a little bit farther, it's a hard surface runway configuration with also distant measuring equipment like a VOR, Vector Omni Range, or a VOR DME or a VORTAC. A lot of those are navigational aids, and we'll be talking through those a little bit later in this course, and also how you can use them to determine where you're going to be flying with NOTAMS. If you keep going down a little bit farther, you have additional airport information. You've got military, you've got heliport selected, unverified, abandoned paved landmarks. All of that plays a vital role in how you can utilize this chart. So as we get to the additional information on the legend, there's a lot of it there. And take your time and learn it, because if you're a pilot and you have flown, this is going to be secondhand knowledge to you. But as you're gaining insight and knowledge starting out in the aviation industry, we're giving you a crash course in this information. So when you look at this legend for airport data, as we pull it up full screen, let's walk through some of this, because there is information that you do need to know if you're going to be operating a UAS in and around an airport. So here we are looking at the airport data full screen. If you notice on the right-hand side, you're going to see near the top FSS, that's Flight Service Station. And you're going to have, let's say at the 9 o'clock position, it says CT 118.3. That indicates that there is a control tower. The 118.3 happens to be their airport or radio frequency. Unless you have a two-way radio and you want to contact them, you're going to have to pick up the phone and call them on a designated line. The ATIS is 123.8 for this location. That is an airport transcribed information system. This is what happens when pilots get into the plane and get ready to taxi. They'll put their radio to 123.8 at this specific airport, and there's a recording of information, runway information, taxi information, weather, takeoff information, any flight information that would be deemed safe to help them fly their aircraft safer. Once they get that information, they'll be given a code. This is information alpha or information Charlie. Then when they contact the tower as they taxi towards the runway, they're going to say, this is N88907 POP. We're getting ready to taxi for the numbers. We have information alpha. That tells the control tower that they received all the pertinent information before they take off. It makes them much safer. But for you as an SUAS pilot, you just need to know that there's a control tower there and that there is information that's available on a radio, but you can get that same information by just going to a website and checking the latest NOTAMS and flight information, which was given in a different course section within the content. Okay, if you look down a little bit farther, you're going to see a bunch of other numbers. 122.95, that's a Unicom, which is a navigational aid number. And the basic information of ASOS and AWOS. This is another one. Automatic Weather Information Station is what this is. All the weather information is reported every half hour or every hour at the airport. And that information is made available to you on a number of weather sites that you can also find, which I'm sure some of you have looked. There's a UAVweather.com. That information has all of that right there for you. And all of that comes from this information right here. There's a lot here, but the basic knowledge is that you understand if there's a control tower or if there isn't, because that determines how you're going to be operating within that airspace. Now let's get to navigational aids. This is critical. You need to know this. So if you have other noises going on right now and you need to concentrate, turn everything else off and listen very carefully. As we prepare flight, we have to make sure that we file NOTAMs, which are notices to airmen. You receive that information in another section of this course. It's apparent that there are a lot of people who are flying SUAS that don't do it. The minute you start launching that aircraft into the airspace, we as pilots need to know where you're going to be and where you're going to be operating, but it's up to you to make sure that you pinpoint that location. So as we pull the navigational aids legend up full screen, I want to walk you through it. Starting at the upper left, you're going to see a VHF Omni Range, VOR. The symbol just below it is VORTAC. That is more designed for military and public use in navigation. You also have an NDB, a non-directional radio beacon. Below that one, you have a non-direction beacon with DME, distant measuring equipment. This aids pilots when they're flying from point A to point B to be able to put it into their computer system, and they can fly autopilot, tells them how far they are from one airport to the next. Now here's the critical part for you. Some airports on these sectional charts, if you're going to be putting in where you're going to be flying, you would say, I'm going to be flying from Traverse City Airport. So you take the very center of the airport and you take a ruler and you draw the line out and you'll say, I'm going to be 30 degrees northeast of the airport at 25 miles. But in this case for Traverse City, it actually has a distant measuring piece of equipment called a VOR. So it's not going to be from the airport unless that's where the VOR is located. In Traverse City, it's actually located to the southeast part of the airport, actually south-southeast of the airport. So I'm going to run you through an example of how that looks and how that works coming up in a couple of minutes. It's going to be confusing, but once you understand how to read it on a map and what you're looking for, you'll be able to plot your NOTAMs with ease and be accurate the first time around. When you're plotting your NOTAMs, always look for any obstructions that are going to be out there. Let's pull up the Topographical Information and Obstructions legend. You're going to notice in the center of the page, which is probably the most vital, are towers. And those towers could be radio towers, cell towers, any kind of tower that's going to be in the air. You also are going to have other information about different bases and different heights when it comes to the airspace that you're going to be in. It'll talk about dams, it'll talk about railroad tracks. All of that information is found in the obstructions part. Learn the symbols, learn and understand where they are on a chart, how high they are, and how they operate, and what it means to you. There's also going to be a section in the bottom left-hand corner. If you look at the three columns, look from the, I would say probably towards the bottom on the left-hand side. See that blue line where it says 132 degrees and there's a V next to it? Well, that V69 is a vector. And that vector is an airplane route, much similar to a highway that we drive. These are highways in the sky. And those numbers are critical, not just that they give direction, but the amount of numbers are critical and crucial to whether you should be flying in that area or not. Believe it or not, if there's a line that has VR with 4 digits, that means that the military can fly below 500 feet and they can be flying right into your UAS. But you didn't know that. You will in this course. So let's take a look at the sectional chart here and blow it up a bit. Take it full screen. Remember I told you about Traverse City? There's the airport right at the base of the 2 bays, big and blue. But that's not where the VOR is. If you look to the center of the compass circle, it happens to be to the south-southeast at about 175-degree radial, and it's about 6 miles away. When you're going to be plotting a NOTAM, you want to use the navigational aid as your center point, no matter where you're going to be flying in and around that region. It could be 10 miles away, it could be 40 miles away. Use the navigational aid. If there is no navigational aid, you can use the center point of the airport. So look at your sectional maps where you're going to be flying and look at where the navigational aids are and look at where the airports that don't have those. And when you plot them in a NOTAM, it's going to pop up a little blue dot. Make sure that blue dot is indicative of where you're actually going to fly. Don't just stick it on there, take off and run and fly because it needs to be accurate. If you input inaccurate information on a NOTAM, the FAA will become knocking, especially if there's an accident. Now let's get to the highest and lowest points on the map, specifically the box to the left, or to the right rather. See where that number 12.5 is? That would be 12,500 feet. And the box just below it, you're looking at a green box there. That indicates the height of 1,719 feet, all the way to sea level. We're talking about military training routes, or MTRs. The heights at which they're going to be flying are going to be indicative on this map. So let's take a look now at Class C airspace. This is airspace information for you to be able to operate. We're going to pick Burbank as a Class C airspace. So as we pull this up full screen, let's walk you through it from the top to bottom. For any type of NOTAM that you're going to have, it's going to have Class airspace and that information. And the appropriate information is always going to be found in the NOTAM section. So for instance, if you're looking for flying in a certain area like Burbank Class C, notice that purple arcing line and the color of it and the size of it. Now Boise Class C is a little bit different. The line isn't quite as thick. Now look down a little bit farther, you're going to see 2 sets of numbers. It likes a division number, so to speak. You have 40 and 38, or excuse me, 48 and 30, and you have T and surface. What do those numbers mean? Well, the 48 is the ceiling of the Class C airspace in hundreds of feet, MSL, mean sea level. The 30 is the floor of Class C in hundreds of feet, MSL. Those numbers are critical to you because you're going to be finding that on charts and maps, not just for the test, but if you're going to be flying in and around that area. So in looking at Class C airspace, we're showing numbers and abbreviated numbers on that. And this happens to be an example of 48 and 30. The 48 indicates the ceiling of the airspace you're going to be flying in, the Class C airspace. The 30 happens to be the base. So the MSL ceiling and floor altitudes of each sector are shown in the solid magenta figures, which you just saw right there, but the last zeros are eliminated. So let's run through a quick quiz here. What is the floor of the Savannah Class C airspace at the shelf area? So this is the outer circle that we're talking about. So use the following chart, put it up on the screen. There's the chart for you to look at. Again, the question is, what is the floor of the Savannah Class C airspace at the shelf area, the outer circle? If you came up with 1,300 feet MSL, you are correct. You've got 41 and 13. 41 is the ceiling, 13 is the base. You add the 2 zeros, it is MSL. So the answer is 1,300 feet MSL. Now let's talk about military training routes, or MTRs. As shown on the sectionals and on other charts, they're identified by route designators. So if you look on the screen here, you can see VR 1667, VR 1617, VR 1638, and VR 1668. And arrows pointing in different directions. Remember I talked to you a little bit earlier in this course about It's the numbers after the designator that are extremely important. In this case, for our purpose with SUAS flight, there are 4 numbers here. That indicates military routes flying below 500 feet. They get to separate themselves from visual flight rules. Route designators are shown in solid black on the route center line, positioned along the route for continuity. Now the designator IR or VR is not repeated when 2 or more routes are established over the same airspace. So an example would be IR 201, 205, 227, 229. It's all going to be the same. So the IR is then pulled from the second, third, fourth set of numbers. Now the routes that are numbered 001 through 099 are shown as IR1 or VR99, eliminating the initial zeros. The direction of flight along the route is indicated by small arrowheads adjacent to and in conjunction with each route designator. That is key for you to understand because of the direction of the flight as well as the altitude. The following note appears on sectionals. Notice that box in the right-hand corner there. There are IFR, which is called IR, and VFR, which is often referred to as VR routes. And here's the route identification, and I put it in bold. Routes at or below 1,500 feet above ground level with no segment above 1,500 feet are identified by 4-digit numbers like VR1007. These routes are used by military to separate themselves when they're operating, meaning they can fly below 500 feet, right into your airspace of 400 feet, 300, or 200 feet. They are allowed that. It is on the sectional chart. And if and when you operate in that area, you have to be cognizant of where those military aircraft are going to be operated and when they're going to be operating. Now, routes above 1,500 feet AGL, some segments of these routes may be below 1,500 feet, but mostly they are above. They're identified by 3 or fewer digit numbers. And these routes are developed for flight under instrument flight rules. MTRs can vary in width. They can go from anywhere between 4 miles up to 16 miles at times. And detailed route width information is available in the Flight Information publication, otherwise known as FLIPS. Special military activity areas are indicated on sectionals by a box, and it's in black type information. The note contains radio frequency information for obtaining area activity status if you had a radio you could listen to. Safest thing to do in this one here is notice the NOTAMS, find out if and where they're going to be operating, contact the local tower in that area, and try to get approval if you can. Don't just operate and take off in that area because military aircraft travel at a high rate of speed and you want to keep that airspace safe for them as well as for you. So now let's refer to the next slide for the reference of the chart. This chart that pops up, the chart shows a gray line with VR1667, VR1617, VR1638, and VR1668. Now, could this area present a hazard to the operations of a small SUAS? If you're thinking no, you might want to go back and relook at the last couple of minutes. We talked about this section. It's a military training route. Now, is it from 1,500 feet AGL, or can they separate from that manned aircraft? It would be C. The defined route provides traffic separation to manned aircraft. So not all aircraft are going to be operating above 500 feet. These have a special designator where they can operate below 500 feet. So the chart that we showed you, you saw where those 4 numbers are. Look for those when you're in and around planning to fly your SUAS. Now let's take a look at the thoughts of NOTAMS. Here's one thing you really need to know. Some navigational locations may be separated from the actual airport. We talked about that. In this case, the one centered in the circle located southwest of Traverse City Airport. So when you're plotting your NOTAM, always plot from the navigational point. If none is available, then use the center point of the airport. This could be on the test. And here's the impact that it'll have. So let's pull up this chart here and show you the examples of making a mistake and how to correct it. Your flight is expected to be northeast of the airport near the water, which is where you want to fly. Look at the green circle that you have up on the screen there. Instead, your flight was plotted to be northeast of the navigational aids shown on the map, which is the red circle. How did that happen? Because you took the airport and used that as a center point. And you drew a line out and you pointed where you wanted to fly. But when you entered that information into the NOTAM, it came back with a blue dot somewhere close to the DME, the distant measuring equipment, that radio beacon that you see there. That's because it took the measuring information from the center of the VOR, which is in the center of that compass. This is what can happen when you incorrectly input the direction and distance of where you plan to fly. This is critical because the NDB happens to be on a flight path towards the landing runway at Traverse City Airport. Pilots would need to know that. And you want to play it safe anyway. So make sure that dot that shows up on the NOTAM to give you an indication of where you think you're going to be flying, make sure that dot is exactly where you plan on flying. Now, we gave you a crash course in the instructions of the charts to help you prepare not just for the FAA test, but to also make you a better SUAS pilot. If you want to know more about these charts, here's a website you can go to for all the information. It's Aeronautical Charts and the User Guide, and it is pages and pages of information. Don't just learn it once and put it away. Try to stay active and current in it because every so many months, new information is posted, and as cell towers become more prevalent, they end up on the map, usually 6 months later. So be cognizant of that. Take a lot of time and learn how these sectional charts are used and how they can benefit you, and you'll be even more prepared to take the FAA Aeronautical Knowledge Test. Thanks for watching.